Download this code from codegive.com, link in the description below. Certainly. In software development, small changes in code can sometimes lead to unexpected issues, especially when the code base is large or complex. This tutorial will explore the concept of how a minor modification can have significant consequences, using a code example to illustrate the point. Understanding the issue. When working with a code base, developers often make small changes to improve functionality or fix bugs. However, these changes can inadvertently introduce new bugs or cause existing features to malfunction, especially if the code is interconnected or if there is a lack of proper testing. Code example. Let's consider a simplified example using Python. Imagine we have a function that processes a list of numbers and calculates their average. The original code looks like this. Python. Def calculate _average, nums. If not nums, check if the list is empty. Return 0. Return sum, nums, /len, nums. Example usage. Numbers equals 10, 20, 30. Average equals calculate _average, numbers. Print, f, the average is, average. Original functionality. 1. The function calculate _average checks if the input list nums is empty. 2. If it is, it returns 0. 3. If not, it calculates the average and returns it. Small change. Now, let's say a developer makes a small change to modify how the function handles empty lists. Python. Def calculate _average, nums. If not nums, check if the list is empty. Return none changed from 0 to none. Return sum, nums, /len, nums. Example usage. Numbers equals 10, 20, 30. Average equals calculate _average, numbers. Print, f, the average is, average. Impact of the change. 1. Change overview *. The developer changed the return value from 0 to none for empty lists. 2. Potential consequences *. If other parts of the code expect a numeric value, example 0, they may break or produce incorrect results if they receive none. This can lead to exceptions in downstream code where the average is used. Illustrating the impact. Let's modify a downstream function that uses the average. Python. Def display _average, average. If average is none, now checks for none instead of 0. Print, no average available. Else. Print, f, the average is, average. 2 f. Example usage. Numbers equals. Average equals calculate _average, numbers. Display _average, average. Result of the change. With the modified calculate _average function, if numbers is an empty list, the output will be no average available. This seems fine, but if any part of the program assumes that 0 is the output for an empty list and attempts calculations with it, it could lead to errors or incorrect behavior. Best practices to avoid such issues. 1. Unit testing *. Always write unit tests for functions to ensure they behave as expected under various conditions, including edge cases like empty lists. 2. Code reviews *. Conduct thorough code reviews to catch potential issues arising from small changes. 3. Documentation *. Document any changes made to the code, especially if they alter the expected behavior. 4. Consistent return types *. Aim to keep the return types consistent, example always returning a number or raising exceptions. 5. Consider side effects *. Be aware of how your changes might affect other parts of the code base. Conclusion. This tutorial illustrates how a small change in code can lead to significant consequences, especially in complex systems where assumptions about data types and return values are intertwined. By following best practices like testing, code reviews, and maintaining clear documentation, developers can mitigate the risks associated with such changes.